Welcome to TechDaily.ai, your shortcut to staying well informed without all the noise. Today, we're doing a deep dive into something a lot of you have asked about navigating the, let's say, sometimes complex world of cloud storage. And this deep dive is brought to you by Stonefly. They're your trusted solution provider and advisor, really. Experts across enterprise storage, backup disaster recovery, hyper-converged setups like VMware, Hyper-V, Proxmox clusters, AI servers too, SA365, that's their turnkey security appliance, and of course, public and private cloud. You should definitely check out stonefly.com to see how they can help optimize your whole infrastructure. Okay, so our mission for today, we're going to unpack the exact differences between the three main types of cloud storage, block, object, and file. But maybe more importantly, we'll look at how you can actually optimize costs and leverage these for new stuff like AI. It's really about giving you more than just definitions. We want to give you some surprising facts, maybe, and practical insights that could really impact your data strategy. Let's unpack this. Yeah, let's face it, block, object, file storage.
It can sound a bit like jargon, right? If you're not,
Right.
deep in cloud architecture daily. But by the end of this deep dive, you'll have a much clearer picture, hopefully, of what each one is and, crucially, why it matters for your specific needs. So maybe let's kick things off with object storage. When we talk about just vast amounts of unstructured data, I'm thinking huge video libraries, image archives, massive data lakes for analytics, web content. Object storage seems to be the name that always comes up. Why is it so dominant there?
Well, that's really because object storage was, built for the cloud right from the start. It stores data as these discrete objects. And an object isn't just the data itself.
Okay.
It also includes rich, often custom, metadata, that's the data about the data, and a unique ID.
Uh-huh.
Now, instead of a traditional folder structure like you'd see in your laptop, imagine a giant, completely flat space.
Okay.
Every piece of data just lives there with its description.
Uh-huh.
And that flat namespace, that's exactly why it offers, well, pretty much unparalleled scalability. We're talking petabytes, billions of objects. It makes it incredibly cost-effective for truly massive data volumes.
Right, like a kind of limitless digital vault. But what's maybe a less obvious aspect of object storage that businesses might overlook when they're trying to calculate the costs?
That's a really good question, because while object storage is, known for its low cost per gigabyte, a surprising thing many miss is that the real cost isn't always just storage. It's often in the access.
Access. How so?
Egress fees, the charges for moving data out of the cloud.
Yeah.
And also API call costs. Those can turn your supposedly cheap storage into a bit of a budget monster if you're not really careful about your access patterns.
I see.
So it's perfect for data that doesn't change much but needs to be accessible, maybe globally, on a massive scale. Think archiving, media storage, big data analytics like with Amazon S3, Google Cloud Storage, Azure Blob Storage. But if you're constantly pulling data out, those egress costs can really bite you.
That's a critical point. Okay, so if object storage is the scalable, cost-effective giant for vast archives, what about applications that need raw speed, precision? Where does block storage fit into all this?
Right, block storage, that's your speed and precision champion, exactly.
Yeah.
It works by splitting any data into these fixed-size chunks or blocks. Each one gets a unique address.
Okay.
This lets applications access data very granularly. You can think of it almost like a hard drive directly attached to your server, but it's virtualized in the cloud.
So more direct.
Yeah, exactly. It's a more direct pipeline to the data.
Mhm.
It doesn't have that extra file system layer that, say, file storage adds on top. And that's what gives it the really low latency and high input-output, I/O performance. Super efficient for data that changes frequently. And the surprising part, it's often the invisible backbone for almost everything else in the cloud. Even managed file systems are often built on top of block storage underneath. Understanding that helps you kind of pinpoint where performance bottlenecks might actually be happening.
Okay, so if you're running, let's say, a high transaction database, like a relational database, or you need to boot up virtual machines, containers really fast, block storage is the way to go. Its flexibility across different operating systems, its ability to handle constant rapid changes efficiently, that makes it ideal. And that's why you see it powering services like AWS, EBS, Azure Managed Disks, GCP Persistent Disks. It's all about that fast, direct control.
Right. And finally, then, we have file storage. This is probably the model most people find, most familiar, isn't it? It's like your computer's file system, folders within folders, but scaled up and shared in the cloud.
Exactly.
Seems like the obvious choice for collaboration, but what are its unique points in a cloud context?
Precisely. File storage works with that traditional hierarchy files, folders that we all use every day. It provides shared access using common network file protocols like NFS, which is Network File System, and SMB, Server Message Block.
Right, the standard.
Yeah, standard ways computers share files over a network. And it uses user and group permissions for security, access control, things like that. It's incredibly intuitive for, actual people interacting with files, for collaborative environments.
So shared drives, team documents, perfect for that. Shared drives, team docs, internal documentation. The trade-off, though, is that while it offers pretty good performance for that kind of shared access, it often hits scaling limits compared to object storage. That inherent hierarchy just gets complex at massive scale. It's really designed more for human collaboration than, say, huge machine-driven scale.
Okay, that clarifies the three main types. So we have object, block, and file. What do they actually have in common underneath it all? And maybe more importantly, where do their differences really matter for your business decisions?
Yeah, there's actually quite a bit of common ground, surprisingly. All three, object, block, file, they all provide robust data persistence, meaning your data stays intact, available usually through things like replication, checksums to detect corruption.
Yeah.
They're all accessible over network using APIs, which gives you great remote access for users, applications. All three can scale to handle large volumes of data, though in different ways, as we discussed. And critically, all three support strong data security features encryption, both when data is stored, so at rest, and when it's moving in transit.
Right, security's key.
Absolutely. And they all provide ways to manage metadata, too, for organizing and finding your data later.
Okay, seeing the common threads is helpful, but the real game changer is understanding the distinctions, isn't it? Because that's where you make those strategic calls. Let's talk about file management. If a business has existing applications, what do they need to think about when integrating with these storage types?
That's a really key point. With object storage, because of that flat structure we talked about, existing applications often need some changes. You might need new code, new APIs to talk to it properly. Block storage, well, it gives you raw disk space. But if you want a shared file system feel, you need to build that layer on top, which means more management overhead. File storage, though, that's the easy one here. It natively supports those common file protocols, NFS, SMB, and the permissions.
Yeah.
So existing apps often just work, sometimes with minimal changes. Makes it very straightforward for familiar workflows.
And metadata, we know that's crucial for finding data later. How different are they and what you can actually do with metadata?
Object storage really shines there. It lets you define almost unlimited custom metadata. You can add tags, descriptions, whatever fields are specific to your business needs. That's invaluable for, say, deep data analytics or complex search.
Right.
Block storage, on the other hand, uses minimal metadata. It prioritizes efficiency and speed, just using unique block identifiers mainly. File storage has, well, pretty limited metadata, usually just the basics relevant to the file itself.
Yeah.
Name, size, creation date, modification date, that sort of thing.
Performance is always a huge factor. What are the trade-offs we're making across these three?
Okay, performance. Block storage generally offers the highest performance, lowest latency, and really rapid data transfer rates. Perfect for those I/O-intensive transactional tasks. Thinks databases again.
Yep.
Object storage, it prioritizes quantity, maybe resilience, over immediate availability. So it tends to have a bit more latency, maybe lower throughput per object. That's usually fine for archival or big data where you're processing vast amounts, but don't need sub-millisecond access to every piece.
Makes sense.
And file storage. It offers good, solid performance for shared access for those collaborative environments. But its main goal isn't raw speed like block storage. It's more about that collaborative ease and familiarity.
And if we peek under the hood at the actual physical infrastructure in the cloud, are they built the same way?
Oh, not at all. Object storage typically relies on a massive distributed environment. Big storage spread across many, many nodes, sometimes even multiple data centers, which gives it extreme resilience. Block storage often uses configurations like RAID arrays, fast SSDs, sometimes HDDs, for that direct high-performance feel. File storage in the cloud, well, it often uses dedicated hardware like network-attached storage and AS appliances, or it might actually be built using underlying block storage, but presented to you as a shared file system.
Got it. And finally, scalability. If I need to store just astronomical amounts of data, which one's my best friend?
Object storage, hands down. It offers near infinite scaling, really. It's designed from the ground up to handle petabytes, exabyte, billions, even trillions of objects seamlessly.
Wow.
Block storage scales too, but you scale it by adding more volumes or bigger volumes. Its ability to scale often depends on how well the instance or application using it can handle the increased I/O demands. File storage, because of that hierarchy, is generally the least scalable of the three. Managing that tree structure at a massive, massive scale just becomes inherently complex.
So yeah, understanding these differences isn't just like academic knowledge, it's fundamental. It's a strategic decision that directly impacts your costs, your performance, your operational effectiveness, really, depending on your specific workloads. And speaking of costs, let's dive into that because it's one of the biggest headaches in cloud environments, right? Uncontrolled storage expenses. It can feel like your budget is just quietly disappearing. The mantra here really needs to be start small, scale fast.
That's such a crucial mindset. With block storage, for example, avoiding over-provisioning right from the start is absolutely key. Cloud environments give you amazing flexibility to scale up easily when you need it. There's a great real-world example. Company A, they provide a popular collaboration platform. They migrated their AWS EBS volumes from the older GP2 type to the newer GP3. And the result? They saved over $600,000 a year.
600,000, wow.
Yeah. And it wasn't just cost savings. GP3 actually gave them significantly better baseline performance, more flexible IOPS scaling. They pulled it off through really careful pre-migration analysis, using native AWS tools like Elastic Volumes and Data Migration Service for a smooth transition, and then continuous monitoring afterwards with tools like CloudWatch to keep things optimized.
That's a massive saving and better performance. What are some other, maybe more everyday, practical ways to optimize those block storage costs?
Okay, another big one. Only use provisioned IOPS when you genuinely need that guaranteed high performance. Analyze your application's actual I/O needs. Often the standard performance is fine, or you can scale IOPS dynamically. Pay only for what you utilize.
Right, don't pay for peak if you're not peaking.
Exactly. And automate the cleanup. Set up ways to prune unused volumes. You can use tools like AWS Lambda or Azure Automation to monitor your volumes. Automatically detach ones that haven't been active for a while. Stops those quiet budget leaks. And don't forget snapshot management. Snapshots are great for backups, but they cost money. Implement automated pruning based on clear retention policies. Keep what you need for compliance, but get rid of old ones. And consider moving older, long-term backup snapshots to cheaper tiered storage, like Amazon S3's Glacier Deep Archive.
Okay, so if block storage optimization is about efficiency, right-sizing, and cleanup, then object storage seems to be more about clever tiering and really managing that access cost we talked about. How does choosing the right storage class make such a difference to the bill there?
Well, yeah, you've got a whole spectrum of options. There's standard for data you access frequently. Then there's intelligent tiering, which is quite clever. It automatically moves data between frequent and infrequent access tiers based on how you actually use it.
Saves you having to guess. Exactly. Then you get into the more budget-friendly options like standard IA, infrequent access, and one zone IA for stuff you touch less often. And then the really low-cost options like Glacier and Glacier Deep Archive for long-term archiving, where you can wait a bit longer to get the data back. The absolute key is matching your data's access pattern to the right price tier.
And case studies really illustrate this point well. Let's take Musify, a music streaming platform. They managed to slash their cloud bill by an incredible 70%.
70%? How?
By strategically using Backblaze B2 for storage and Cloudflare for their CDN. Now, they were egressing about a petabyte of data every month. Normally, that would generate massive egress fees from a major cloud provider.
Yeah, a petabyte is huge.
Huge. But Backblaze and Cloudflare are part of something called the Bandwidth Alliance. This meant Musify got free data transfer, free egress between where their music files were stored, Backblaze, and Cloudflare's edge servers worldwide. That, combined with a really high cache hit ratio, about 90% in their CDN layer, just dramatically cut their costs, while still giving users great streaming performance everywhere.
Wow, so it wasn't just the storage costs, it was understanding the network and egress costs. That's smart.
It shows how network strategy is intrinsically linked to object storage costs, especially at scale.
Definitely. Now for file storage, the familiar one, what are the main ways to keep expenses in check there given its more traditional structure? You can still leverage cost-effective tiers sometimes. Look for services like, say, Amazon EFS and frequent access. Similar idea, it automatically moves files that haven't been accessed recently to a lower cost storage tier, but they remain immediately accessible if needed. And also, sometimes you need to step back and ask, do I really need file storage for this? For data that's accessed very rarely, or maybe just used for backups or archives, Perhaps object storage, blob storage, might actually be a much more cost-effective solution than paying for a full file system interface.
That makes sense.
Yeah.
Step back and evaluate the use case. Okay, beyond those specific tips for each type, are there broader, maybe more advanced techniques that apply across the board?
Oh, absolutely. For really high-volume users, don't underestimate the power of negotiation. Talking directly to your cloud provider about volume discounts, custom rate cards, that can lead to substantial savings if your usage is significant.
Right, leverage your scale.
Exactly. And always push for data compression and deduplication. Across all storage types, this can dramatically shrink your storage footprint, saving you money on capacity and sometimes even transfer costs.
For big migrations from on-premises, consider using physical data transfer devices. Things like AWS Snowball or Azure Databox. They offer secure, often much more cost-effective ways to move terabytes or petabytes offline, avoiding potentially massive network transfer charges and time.
Okay, for those big initial moves.
Yeah. And optimize your backups. Implement tiered backups. Maybe keep recent backups hot, older ones colder. Use deduplication specifically for your backup data. Have really clear backup retention policies. Protect your data robustly, but don't keep unnecessary copies forever.
Makes sense.
Also, if you're using Azure, look into their storage reservations. If you have predictable workloads, you can commit to specific capacity for, say, 1 or 3 years and unlock pretty significant discounts on blob storage, managed disks, and their elastic file system.
So predictability pays off.
It does. And finally, really embrace proactive retention policies and data lifecycle management. Think of your storage not as a static thing, but as a dynamic ecosystem. Set up rules to automatically organize data, move it between tiers, archive it, or even delete it when it's no longer needed, all based on its usage patterns and business value. That ensures optimal performance and cost optimization over time.
It feels like all these storage decisions, they're becoming increasingly tied into the bigger picture, aren't they? Our AI ambitions, the ever-present cybersecurity threats. It's not just about bits and bytes anymore, it's about strategic data readiness.
Absolutely, you hit the nail on the head. AI isn't some future thing. It's a top investment priority today for nearly half, 47% of organizations. And get this, 92% are finding budget for it somehow.
92%.
Yeah, 71% are allocating additional funds, and 22% are reallocating from other areas. AI is happening, but but there's a significant hurdle. Only about 1 in 5 organizations feel confident that their data is actually AI ready.
Only 1 in 5. That's low.
It is. It highlights this massive challenge in just unifying, organizing, and preparing data for AI initiatives. We're also seeing cloud spending go up by an average of 18% specifically to support these AI goals. And the challenges aren't just technical. Data security and privacy concerns. That affects 34% of organizations trying to implement AI. And a shortage of skilled people. That impacts 27%.
And how does storage fit into that AI picture?
Object storage especially is becoming absolutely critical for the whole AI lifecycle. From storing the vast amounts of training data needed, building data lakes, right through to supporting the actual model training, deployment, and managing the content generated by AI. Its scalability and ability to handle unstructured data are key.
Right. And then on the flip side of opportunity, there's risk. The cybersecurity imperative, you mentioned a confidence gap.
Yeah, it's quite striking. Well, about 63% of firms say they're confident they can recover from cyber attacks.
Which sounds okay.
Right, but then you look at the reality. 45% actually struggled to recover from an attack in the last year. So there's a big gap between perceived readiness and actual experience, and the cost of that struggle is staggering. Organizations are taking, on average, 5 weeks to recover from a major cyber attack.
5 weeks? That's huge downtime.
It is, and 72% take more than a week. Think about the lost revenue, the productivity hit, the reputational damage. It's massive.
And what's maybe even more surprising is the lack of some basic cyber resilience measures, right?
It's quite shocking, really. 53%, more than half of firms, admit they don't have real-time attack detection tools in place. And another 53% say their critical data isn't properly backed up. Immutable, meaning it can't be altered or deleted, and easily recoverable.
Wow. That's a huge vulnerability just waiting to be exploited.
It really is. And it
Yep.
drives home why thinking about things like a hybrid cloud model isn't just about flexibility or maybe cost savings. It's actually a very effective risk mitigation strategy. You can integrate robust disaster recovery, ransomware protection, things like immutability at a fundamental level.
So, yeah, to kind of wrap things up here, choosing the right cloud storage or the right mix of cloud storage, it isn't just some technical detail buried in the IT department. It's a profound strategic decision. It impacts your costs, your performance, and maybe most importantly today, your future readiness for both the demands of AI and those ever-present cybersecurity threats.
That is the crucial takeaway, absolutely. A modern, resilient infrastructure rarely relies on just one type of storage anymore. It's almost always about leveraging a smart blend using block, object, and file storage, where each makes the most sense, tailoring the solution to the specific need.
Right.
That ensures you get better performance for critical apps, you get enhanced reliability because you're using diverse solutions, and ultimately, probably less operational complexity than trying to force one solution to everything. And remember, this journey towards cost optimization, towards true data readiness for AI and security, it's continuous. It requires active monitoring, strategic adaptation, and a really proactive mindset.
Definitely food for thought. And maybe here's a final thought for you, the listener, to mull over. How confident are you really that your current data management strategy is truly fit for purpose in this landscape? This landscape where AI is demanding more accessible data than ever, and cyber threats are just constantly looming large. Before we sign off, just a quick reminder from our sponsor, Stonefly. If optimizing your storage, especially with security in mind, is on your radar, you should definitely look into their specific offer. The 100 TB immutable and air-gapped SSO NAS for $8,995.11. Given our discussion today about immutability and security against cyber threats, that sounds directly relevant. You can learn more about how Stonefly can help secure and streamline your data by visiting stonefly.com.